question says, what is the major product of the following synthesis? So we basically have a two-step reaction going on, one reaction with HBr and then two reaction with tert butoxide. Our starting material is an alcohol. So let's kind of consider what our options are as far as reactions. Our alcohol has a secondary alpha carbon, and the HBr is a strong acid. Whenever you have an alcohol reacting with a strong acid, what we're essentially doing is we're taking a bad leaving group, the hydroxide, and we're converting it into a better leaving group, which is water. So let's kind of draw that out and see what it would look like. So first up, proton transfer. And we're making a water molecule, which is now a good leaving group. And we have this guy. What happens next is we have to figure out what mechanism is happening. Typically with HBr or HX, we see substitution exclusively. So the key is it SN2 or is it SN1? Because our alcohol is a secondary substrate, it's got a lot of more steric hindrance going on. So it's going to favor the SN1 process. That's super important because it tells us what our intermediate is. We lose the water and we make a carbocation in this reaction. So the carbocation, like all carbocations, is susceptible to rearrangements. So we need to check our carbocation and think, can it rearrange? Okay, this carbocation is secondary, and there is a hydrogen over on this neighboring carbon that can move over to make it into a more stable tertiary carbocation. So we do see a carbocation rearrangement here. I'm gonna write it in, carbocation rearrangement. Right, that's super important because that's going to help us figure out what the major product is. The major product will come from the more stable carbocation. After the carbocation, we're going to have a bromide come in and attack that more stable carbocation. And the product after reaction 1 is going to look like this. Right, so we have a tertiary alkyl halide. So that's all just step 1, reaction with HBr. What happens next? What happens with the tert butoxide? The tert butoxide is a strong, bulky base only. It functions predominantly as a base because it's super bulky. So a good nucleophile is small. If you have a big bulky base, it's not also going to be a nucleophile. So when you have a big bulky base, we have to think about what's going to happen with a tertiary alkyl halide. That's going to favor an E2 mechanism. With E2, whenever you have a big bulky base, there is the opportunity for the Hoffman product to be favored over the Zaitsev product. So if we take a look at our tertiary alkyl halide that's going to be reacting with the tert butoxide, we have kind of 2 different sets of hydrogens to choose from. And the more accessible hydrogens are going to be the one that that big bulky base takes off. If we bring in tert butoxide, it's going to go for one of these more accessible hydrogens and kick it off. And so the major product of this reaction is going to be molecule number 3, where we end up with this di-substituted alkene. If you miss the carbocation rearrangement, you might think that the product is something totally different. So always kind of have that little red flag go off whenever you see a carbocation to remind yourself, think about carbocation rearrangements, right? The second kind of tricky part of this reaction is that big bulky base. Remembering that if you have a bulky base, oftentimes the Hoffman product will be favored over the Zaitsev product. So the answer to this question is C, molecule number 3.